Hello, in this video, I'm going to show you how to summarize a set of quantitative data, such as the one that we have in Chapter 2 demo data under frequency distribution histogram, this pulse rate data into a frequency distribution as well as a histogram. I'll show you how to do it when we were given a lowest class range, class width, as well as using the default from Statcrunch. So first of all, we download this data or copy this to Statcrunch. Use Control V so that it is in Statcrunch. And then just like what we do by hand, if we want to create a frequency distribution, we need to create class ranges. So for example, just like in the homework question, sometimes they actually would tell you, oh, start with the lowest class limit of 60 and then go up to and then the class width of 10. Let's just say that we use the lowest of 60 and the width of 10. So we will create all these lower class limit first, I should say 62, right? 62 something, but we just don't know what it goes to. 70, 80, 90, and I think I don't need to do 100 because the highest number does not go up to like 99 or 100s. Then we do the upper class limit, which is, what should it be? It should be 69 because these are all whole number, and I don't need to do 69.9 or something. This will be 79. So build the lowest class limit and then build the upper class limit. 89 and then do 99. Just like what you do. Oh, just like what you do by hand. 89 to 99. To 99. So this is the class, you can say it's class range, classes, okay, classes. Statcrunch cannot do this for you. You have to do it yourself before you even start. Then you would just do the tallying, usually by hand, and we look at them and then tally into each before we write the frequency. Now, Statcrunch can do this for you automatically. So what you do is you do data. You do data bin. Binning, a binning process is tallying. You tell them that I want to bin pulse rate and I want to use fixed width bin that we have been using, 60, start at 60, and the bin width, which is our class width, is 10, and then you do compute. What happened is they do not do 1, 2, 3, 4 for you. They will tell you for each of this data. I'm really sorry that I don't know why they put it over here. 76 belongs to 70 over to 80. 72 belongs to 70 to 80, like that. It just tells you that what class it belongs to. Now notice that they do not say 70 to 79, and that's the reason why I want you to build this yourself first. They would build it so that the two the lower class limit and the upper class limit of the second one actually overlap. A lot of software do that. Then you will do the frequency. So after you do bin, you do stat tables, because just like the categorical data, now you are putting down the tables. You click on bin, not the original pulse rate. Click on bin, and then you do compute. Okay, so you would have a table that shows 60 to 70 frequency is 8, 70 to 80 is 7, 80 to 90 is 4, 90 to 100 is 1. But that's not what our original class is. Our original class would be 60 to 69, right? Like that. So do not copy this as a frequency distribution, but type it out yourself. So in my case, maybe what I'll do is I'll insert, how do I insert column? Insert a column next to before, right after, I should say after, insert before pulse, bin pulse rate. So right here, this is, and then I'll say 8, 7, 4, 1. And this would be my frequency distribution. So you can use a screenshot to screenshot it if you want to do it by digitally, or you just copy it down. So that's how you produce a frequency distribution. You actually change it into frequency instead of relative frequency. Okay. They actually would give you the relative frequency. Can they give you cumulative frequency? Yeah, they can also give you cumulative frequency if you want to. But again, you do not want to do it, use the classes that they have. The classes are wrong. It should be the classes that you did where the lower class limit of the class before it is different from the upper class limit of the class following it. Okay, so that's one important things I want to mention. I also want to do a second example where I want my class width to be 5 because like what you see, I only have 4 classes, and for most part, if we do a frequency distribution, we do not want to have only 4 classes. It's hard to see the, it's summarized too much. So I'm going to delete these columns, delete classes, frequency column that we just copied, delete all these delete all this first. I'm going to build another class. Let's try to build here, where I start from 60, but then my class width would be 65 or 5. Okay, my class width is 5, so it would be 70, 75, 80, 85, 90, 95, and I think that would be the last class. And then I build the upper class limit. What should it be? It should be 64, right? Oh yeah, 60 to 64. And then this would be 69. And then this would be 74. The upper should be 79 because we only have whole number. 84. Oh, 89. And then, yeah. 94. 99. Okay, so this is the new class, I should say. These are the classes. And I'm supposed to tally, but instead of tallying, we do data bin. Have each data value being binned into a fixed class width of starting from 60, and then the bin width is 5. Okay, in this case, this is a second example. So they would say, well, 76 belongs to 75 to 80, and then you do the table. So stat tables, frequency, the bin pulse rate, compute. So they do not output it onto this data table. They output it in this. And I want you to look carefully. So and then I say, well, I want to insert something. I don't like the fact that they always do the bin next to the class. Insert before the bin pulse rate, so I can put my frequency here, right? So copy the frequency over, and I want you to look carefully. 60 to 64 is actually 60 to 65, so I say 3. 65 to 70, that's 5. 70 to 79 is 70 to 75, so that's 5. 79 to 80 is 79 to 79, that's 2, right? 80 to 84, 80 to 84 is 3. 85 to 89 is 1. 90 to 94, do you see it? 90 to 94? So this is an example that I want to show you where in the output table, if there is a 0 frequency, this frequency table, because they don't know that you're doing a frequency distribution, they're just counting all the bins assignment for you. They don't show it. So you have to manually say 0. And you can see that they are not contiguous from 85 to 90, and there is no 90 to 95. They just skip. If it's 0, they skip it. So in this output from Statcrunch, they will skip all gaps that you're supposed to put a 0 in, and then the last one is 1. So the two issues with the frequency table from Statcrunch, one is the upper limit is not matched or what we're supposed to have, and also they skip all this 0, which is not supposed to be, because then you would not know that these are outliers or etc. So this is the real frequency table. So always make sure that you do this and always copy it back into the real classes to make sure that you have zeros included. Okay, so that's this example. Then the third things I want to show you is in case I want to just, do a frequency table, but no one give me, I'm going to delete all these first. No one give me the class limit, class range, or class width. I just want to look at the frequency table. You can actually do bin first, and then when you do your, okay, so when you do bin, you want to sort them. You can just ask Statcrunch to sort it whatever way that they want to. You don't have to give them the bin width, so they will put it this way. In this case, you notice that their class start from 60, and then their class width is 5. Okay, so you could do that too, if the question does not give you that. But usually in the homework question, they always give you the number. Okay, and then after that, then you do the frequency tables. You do the tables frequency, except you have to be aware that they still do not show any missing bin, like 90 to 94, 90 to 95 does not show up. Okay, so that's the drawback of using Statcrunch to do frequency distribution. If you're interested doing the same thing with Google Sheets and Excel, I have YouTube videos that you can watch, but this video only shows Statcrunch. So I'm going to delete this again. Column, delete, because the last thing I want to show you is how to graph this with a histogram. So it's very easy. You do graph, histogram. Okay, so you have a list of raw data. You want to start from 60, and then your bin width is, say, we can do 10. And then you do compute, and that's it. You don't have to do your classes. Then you might worry, well, what happens if would they skip the 0 if they graph it? Okay, so you do histogram. Let's say you can do it again. In this case, I start from 60, but my width is 5. Remember last time when we do a frequency table, they skip one of the class 0? Oh, but when you do histogram, they don't. It's show up as 0. So histogram actually is better. Okay, so again, you do graph, histogram, you give them the bin start at and bin width, and they would show a histogram for you. They also, if you don't give this, see it is optional, they would just assign something for you. So you say select column. So this is useful in case you just want to know the shapes of the distribution. You don't really care what the classes is. So they will assign a class for you. In this case, the 5 class width is what they assign. Okay. Now, after you do that, I also want you to zoom in here and, maybe edit your title. Oh, this is a histogram of something, histogram of pulse array. So after you do any graph, you're supposed to adjust your x-axis, y-axis, titles. You can change your color and whatever. Okay, so that's how you do frequency distribution and histogram.